For this section, we're going to start looking at special products. And special products are just like when we multiply a polynomial by a polynomial, but something happens to our terms. So for our first special product, we have 3x plus 5, and that all of that is squared. So when we have something, when we have a polynomial where the whole thing is squared, we're actually going to rewrite the polynomial as 3x plus 5 times 3x plus 5. So we have 2 of what the polynomial is. If it was 3x plus 5 and all of that was cubed, then I would have, I would write 3 of those. So then I can just solve it like a normal polynomial, and I'm still going to follow my FOIL method. So I have 3x times 3x gives me a 9x squared plus 15x plus 15x plus 25. And then when I go to simplify that, I'm going to get 3x squared, or 9x squared, excuse me. I get 9x squared plus 30x plus 25. So for this example, I have AC plus 3D, and all of that is squared, so I have my polynomial squared. So this is just like saying that I have 8C plus 3D times 8C plus 3D. And at first I'm going to get a 64C squared plus a 24CD, because I multiplied my coefficients and then I just leave my variables there, plus a 24CD plus a 9D squared. And then my final answer becomes a 64C squared plus 48CD plus 9D squared. Go ahead and pause the video, and I want you to try this one on your own. So when I have 4x, or x plus 4, and the whole quantity is squared, I get x plus 4 times x plus 4. So I'm going to get an x squared plus 4x plus 4x plus 16. So I get x squared plus 8x plus 16. For this example, all that's changed is my operation that's inside the polynomial. And so I'm still going to follow my same steps. I'm going to multiply my polynomial. So I'm going to get x minus 3 times x minus 3. And when I solve this and simplify it, I get x squared minus 3x plus 9, because a negative 3 times a negative 3 is going to give me that positive 9. So I have x squared minus 6x plus 9. And so all that's changed is now, instead of everything being positive, I have this negative term that's in there. So go ahead and pause this video and try this example on your own. So the first thing that I have is I'm going to have a 6p minus 1 times 6p minus 1. And I'm going to get a 36p squared minus a 6p minus 6p plus 1. So I get a 36p squared minus 12p plus 1 is my final answer. Go ahead and pause the video, and I want you to try this one on your own. So I'm going to get a minus 2y times a minus 2y And so my answer is going to be a squared minus 2ya minus 2ya plus a 2y squared. So my final answer is a squared minus 4ya plus 2y squared. For this example, as you can tell in our two polynomials, I have a +3 and then I have a -3 here. So if you start to think, what could possibly happen when I have two polynomials that I'm multiplying? What's going to happen to my terms when there's opposite symbols in there, opposite operations? So let's go ahead and see what happens. So I'm going to multiply 2x squared times 2x squared, and I get a 4x to the 4th. Then a 2x squared times a -3 gives me -6x squared. And then a 2x squared plus 3 gives me plus 6x squared. And then a 3 times a -3 gives me -9. And so then when I go to simplify, I have this -6x squared plus a 6x squared. Well, a -6x squared plus a 6x squared just equals 0. So my middle terms end up actually dropping out. So I'm left with just 4x to the 4th minus 9 is my final answer. Go ahead and pause the video, and I want you to try this one on your own. So I'm going to get a 3n squared, or a 9n squared, plus a 6n minus a 6n minus 4. And my middle terms end up dropping out, so I get 9n squared minus 4 as my final answer.